In this video, we're going to practice working with the multiplication rule for independent events. So as we talked about in the section above this video, it says if A and B are independent. Now, this only works if you have two independent events. If your events are not independent, there is another multiplication rule that we're going to talk about in the next section, but for now, this is all that we have to work with. Then, so if we're working with independent events, then the probability of A and B is just the probability of A times the probability of B. We just multiply their probabilities together. So I'll just have to find their probabilities separately, multiply them, I'll have my answer. So let's take a look at these examples. First example says, what is the probability of getting a heads on a coin flip and getting a 1 on a 6-sided die roll? So in this case, first I want to just kind of make sure, am I working with independent events? Flipping a coin, rolling a die, these two things have nothing to do with each other, so they are going to be independent events. So if I want to talk about the probability that I get a heads, so get a heads, and the probability that I get a 1, get a 1, these two are independent events, so I can look at the probability that I get a head separately from the probability that I get a 1, and then multiply the results together. So if I flip a coin, there's only two outcomes. There's either heads or tails. So we'll say out of the two different outcomes that I have, only one of those is heads. And then we'll multiply that result by the probability that I get a 1 on a 6-sided die roll. So if I'm rolling a die with 6 sides, that means there are 6 total outcomes. And if I think about the numbers that are on that die roll, it's 1, 2, 3, 4, 5, or 6. Only one of those is a 1. It's 1, so 1/2 times 1 over 6. If I multiply these, I should end up with my answer. So if you want to multiply the fractions, you can just multiply straight across. 1 times 1 is 1, and then in my denominator, 2 times 6 gives me 12. Should be 1 over 12. You could also get the decimal versions of these fractions as well, and then just multiply those out. But in this case, 1 over 12, if I wanted to round that and give the decimal version, 0.0833. So again, either one of these, just depending on what the problem is asking for. So we just need to make sure that the two events that we're talking about are independent, and then we can just multiply the probabilities separately. Let's take a look at our next couple of examples. Part B says, suppose that 32.5% of community college students are enrolled in an online course. Suppose that we select 2 community college students at random. What is the probability that both students are enrolled in an online course? So I want essentially the probability that the first is in an online course. And I want the second one to be also in an online course. So in cases like these, we do have to kind of make an assumption here that if we're talking about all community college students and we're picking at random, these are going to be independent, mostly because if we talk about all community college students, that's an extremely large group of individuals. It's a very large population. So we can go ahead and assume that our random samples are going to be independent. So if that's the case, we can find the probability that the first one is an online course, and then multiply that by the probability that the second one is also in an online course. So in this case, well, the probability that the first is in an online course is 32.5%, or 0.325. Okay, we have our first probability. And then the probability that the second is in an online course, well, that's also 32.5%, or 0.325. So I'm just multiplying these two numbers together once again. So 0.325 times 0.325. I'm going to round this to 4 decimal places. 0.1056 then is my answer. So I just needed to multiply those two out. One thing that I like to do is if we're selecting as a number of individuals from a population like this is I like to kind of create these fill in the blanks and say, okay, it's this and this, I'm multiplying them, and then I just need to fill in these probabilities right here. So let's try that out in the next section. In the next example, it says, using the information from part B, what is the probability that neither student is enrolled in an online course? So in this case, I want both students to not be enrolled in an online course. If I wanted to write this out as an AND statement, I want the first to be no online, we'll say, and the second to be not online. So I'm really taking the probability that the first is not enrolled in an online course, and I'm going to multiply that by the probability that the second is also not in an online course. Well, if I want to do this, it would be very helpful to figure out what the probability that someone is not enrolled in an online course is. Well, what's nice is they gave us the probability that the student is enrolled in an online course. It's 32.5%. So I'm going to do a little bit of scratch work down here. I'm going to scroll down a little bit further. The probability that they are not, well, here, let's write it out this way. Probability that they are in an online course, are in online, was 32.5%, or 0.325. If I want to talk about the probability that they are not in an online course, online, I can spell. These two events are in an online course and not in an online course. Those two are complementary. So if I wanted to find the probability that they are not in an online course, I know, hey, from my complementary events formula, probability of A is equal to 1 minus the probability of A complement. So I can just take 1 minus 0.325 to get, let's make sure I'm not making a silly mistake here, 0.675. So the probability that they are not in an online course, is 0.675. So returning then to our problem, the probability that the first is not in an online course, we just said that was 0.675. And the probability that the second is not in an online course is also 0.675. I'm going to go ahead and multiply those two together. So 0.675 times 0.675. That ends up as 0.4556 if I round to 4 decimal places. So in general, when we're looking for these AND probabilities, we are almost always going to be multiplying. Really, the only exception I can think of off the top of my head is if we're working with a contingency table, but if we are given a probability like this, we are most likely going to be multiplying some of these probabilities together.